Hi, I'm Paul Walker. I'm Senior Technical and Development Specialist at Socotec in the Advanced Chemistry and Research Division of Environmental Chemistry. So I've been working here now for 26 years. We started off with the research laboratories of British Rail. Upon privatisations, then we became Socotec eventually. Advanced Chemistry and Research Group is a research and scientific group within Socotec. And we do the weird and wonderful stuff as well as some of the more bespoke analysis for clients. So if a client has a specific problem or a particular analyte that they're looking for, then we will create a bespoke analysis for it. Some of the research work that we do is microplastics. So microplastics is a very hot topic at the moment. It's been around now for a few years. There's a set procedure that you tend to go through. The first thing will be a wet sieving. So we will take the samples, we will pass it through different size sieves, and pass that through underwater. Anything above 5,000 microns is not considered a microplastics, so that will be in the first tray and that will be disposed of. The smaller the microplastics, especially with soil samples, it's extremely difficult to work with the minute samples. So we have to remove the extremely small stuff. So that goes out of the second sieve. Normally in our situation, we're using a 300 micron sieve. So we're left in that sieve, the second sieve, the particles that are between 5,000 and 300 microns. We then move over to the next stage, which is the density flotation. So we'll see that we have our density flotation system, which was custom made by myself. And this is a liquid which has a density of 1.6 grams per mil. We add the material into it, and as you can see in the flotation tank that we have here, that the solid, heavier materials, which is all your sand and stone type materials, will all sink to the bottom. Floating on the top, you can clearly see we have our microplastics, but we also have some of the organic materials, so things like leaf materials, mulch. We will then take off that top layer. And so that will contain our microplastics, but as I say, it will contain some other organic materials which we don't want. So we will then go on to the next stage, which is a digestion stage. So there's different ways of digesting the samples. We happen to use a Fenton's reagent, which is a hydrogen peroxide based digestion. This is what's in the beaker at the moment. And you can see here that it's all bubbling away and the microplastics are there, and which are unaffected by the Fenton's, but it's digesting away all the organic materials. This will stay at around 60 degrees Celsius in this chamber, and it will stay there anywhere between 1 day and a couple of weeks, depending on how much organic material we need to digest away from it. As soon as we've digested all the stuff that we don't want, hopefully we're just left with the microplastics. They are then filtered out just using a normal filtration system, and then we will then move on to the microscopy side of it. So here we have our microscopy setup. So we can then look through the microscope, we can look at the particles, we can look at the shape, the size, the colour of them, we can count them, and then we have a digital image on that camera. On the microscope. So here we can see an image on the screen of some of the microplastics that we're seeing. The identification is based on what the particles look like. So if we actually want to know whether they are actually a microplastic or not, and what kind of microplastic it is, so whether it's a PVC or a polypropylene or something like that, then each particle is isolated and then it's put onto the FTIR microscope, which is the infrared microscope in action, and this will identify what the particle is actually made of. Now, there is a problem with microplastics, is we don't actually know how dangerous they are and the reason why they are dangerous. The British standards and the ISO committees are developing methods for it, and I am one of the UK experts for microplastics to ISO, which are investigating that. Now, there is talk about microplastics being dangerous because of their size, but it could be it's the shape or it's what they're made of that's causing the problems, or it's nothing to do with that and the microplastics are acting as vectors. And it's all the nasty chemicals that the microplastics are dissolved with, so things like toxic metals, chlorinated solvents, brominated flame retardants, things like that. So when you take the microplastic into your body, it doesn't really matter what the microplastic's made of, it's that they're carrying these toxic materials into the body, and that's what's causing the problems. This research is ongoing with lots of universities around the world, and as soon as the toxicology data is more known, then we will know what kind of analysis is actually required to actually analyse these samples within the environment.